Good evening and welcome to Stargazing 2015. What a beautiful night we have for it here. This week sees the UK's biggest astronomical event of the century so far, a nationwide solar eclipse.
We'll bring you images of the eclipse from across the UK and explore the majesty and the detail of this extraordinary event.
And as we gaze at the moon, who better to join us than the legendary Buzz Aldrin?
I'm Brian Cox, he's Darragh O'Brien, and this is Stargazing Live.
Welcome to Jodrell Bank Observatory in Cheshire. This will be our home for the next 3 nights. We will take you from here to the moon, to Mars, and from planet Earth to Pluto.
All that and Buzz Aldrin. Buzz was lunar module pilot for Apollo 11, the first manned mission to land on the moon. Find out whether he thinks our future in space is on the moon, on Mars, or beyond.
Brian's going to be trying his hand at the moon landing with various degrees of success.
Yeah, well, we're crashing.
Yeah. And we'll find out how astronomers ancient and modern can predict solar eclipses so accurately.
We'll take you behind the scenes at Europe's Spacecraft Test Centre, where they make sure the latest space probes don't fall apart on the launch pad. And over the next 3 days, we'll be searching for exploding stars, supernova explosions. With your discoveries, our aim is to revise the known age of the universe.
It's a fabulous night for stargazing, and as ever, we want your stargazing pictures. And of course, we're also here to answer questions. We're here, and Buzz Aldrin is here. So if you have any questions, for example, about walking on the moon, solar eclipses, or space missions, the addresses you need are on the screen right now.
Now, it's time for our first look at what's in the sky tonight. And to do that, here's the newest member of our team, solar physicist Dr. Lucy Green.
Well, thank you, Brian. I am delighted to be out here, although I'm sure you are a lot warmer inside. But I'm joined by a gang from the Liverpool Astronomical Society. Give us a cheer, guys. And just look at this. We have fantastic clear skies at the moment, and we're getting a great view of Jupiter. And you'll be able to see the 4 largest moons perfectly lined up on one side of the planet. And this is a rare event, only happening every 6 years. Now, in the coming nights, this alignment is going to change as the moons go through an extraordinary dance. More on that later on. Please keep your fingers crossed that the skies hold out for us.
Yes, so the moons of Jupiter will be performing for us this week, but that's really only the opening act, because undoubtedly the biggest treat of the week will be on Friday morning, when a solar eclipse will be visible right across the UK. This occurs when the moon gets in the way of the sun and blocks out the light. Now, to view it, and we will say this many, many times, it will be helpful if you had one of these. These are a pair of eclipse glasses, because you cannot look directly at the sun without there being a fairly heavy filter. Right?
This is becoming our image, isn't it?
Yes, this is our thing now. But if you can't get a hold of these, and they are difficult to get a hold of, please go to our website for other ideas for watching it safely. Do not look directly at the sun, because you can do serious damage to your eyesight. This is what you'll be seeing, however, depending on where you are. It could be up to 98% of the sun will be obscured by the moon. This is an animation of what it'll leave, the small smile of the sun at the bottom there. And on top of that, we'll be bringing you live an even rarer event. 230 miles north of Scotland in the Faroe Islands, we'll see a total solar eclipse. Now, a total eclipse can only occur because of a very beautiful coincidence. This is one of the great things about, with stargazing. Something as beautiful as this would occur. Right? This is the sun we want here. Lovely, very, very good.
We should say the puffer sphere is back.
It's good to have our old friend, the puffer sphere, that's spinning around there. This actually flatters the moon to a certain extent, but the sun is 400 times larger than the moon. But luckily for us, where the moon is right now, it is, and this might be a difficult one to get exactly right. Here we go. Oh, there. The moon is 400 times closer than the sun is. So the moon sits directly in front of the sun, creating a total eclipse. Now, the thing about this seems very obvious in some ways, but there's one thing that always puzzles me. If the sun is here and we're here, if the moon is just going around, why does an eclipse just happen every month?
The answer is because everything isn't in a line. So if you change to the Earth, so indeed you're right, if the moon orbited the Earth in the same plane as the Earth and the sun, this is called the plane of the ecliptic, by the way, then you're right, every month the moon would cast its shadow on the surface of the Earth. But it's more complicated than that, because the moon orbits the Earth at an angle of about 5 degrees to this plane. So very often, you can imagine, and this is also moving around, it's quite a complicated system, very often the moon will be cast in a shadow, but because it's above the Earth, the shadow it casts will be out somewhere in space. And then at some later point, as the moon moves around, it could be below the Earth, and then it would be cast in a shadow below the Earth. So it's only when the geometry is just right that the moon aligns correctly, that a shadow is cast from the sun, the moon, onto the Earth and you get an eclipse.
So it's rare that you see an eclipse, but it's particularly rare, and we're the only planet in the solar system that you get a total eclipse. But there are other eclipses throughout the solar system.
Oh, there are, yeah. I mean, this is a beautiful picture. So this is a picture from the surface of Mars, of an eclipse by Mars's moon Phobos. Now, Phobos is about 27 kilometres across. It's a very small moon. As you see, it's not close enough to Mars to completely obscure the sun. But this is a photograph from Curiosity, actually, on the surface of Mars.
This is a photograph taken by a robot we sent to another planet of the planet enjoying an eclipse.
Emphasising that, isn't it? Beautiful.
It's astonishing. Our challenge, therefore, this week is to bring you the very best images of Friday's eclipse. And here's our secret weapon, Liz Bonin.
I've never been called that before.
No, okay, Grant, maybe the sentence ran on in a way that was unfortunate, but Liz, firstly,
Are you shaking my hand?
I am, because
Thank
you've been
you,
here for
Darragh.
5 years, but you've never been here.
5 long years, and
Yeah.
finally I make it to John.
We always send you off all over the
I
world.
know, I'm not that I'm complaining or anything, but it's really nice to be here. Yeah.
However, we only have for the one night because you're heading straight off
I'm
tomorrow.
heading off in the morning and then I come back for Friday night's show. So you
Yeah.
have me zipping up to the Faroes and back, because as much as the larger shadow of the moon covers all of the UK, we get as much as 98% coverage of the sun. The path of totality, as it's called, is passing us by about 150 kilometres to the northwest of Scotland.
So where are you going now?
So I'm heading here. The Faroe Islands just here, because that's where one of the only 2 places on Earth, bits of land, where you can see a total 100% eclipse,
Right,
solar
because
eclipse.
essentially what you're doing is chasing a shadow.
Yeah, I am. We really are chasing it, because not only am I joining about 8,000 eclipse watchers tomorrow night on the Faroe Islands, on Friday morning I'm going up 25,000 feet to really chase that shadow for you.
Above the cloud line.
Above the cloud line. That's the
We can actually show you the
crucial
shadow.
part.
I think we can show you the shadow here. Here we go.
Can
Let's
we?
bring it around here. Spin
like
this
this.
around.
Can I play
Oh,
with
it's fabulous.
this?
Where are we going? Oh, for God's sake.
We've gone
There's
around
the
the planet.
planet. We've gone too far. Here we go. So,
Okay.
have we got the shadow graphic here that we
Here
show?
we are.
There we go. No, that's just day and night passing through. Okay, so you're going to go up there above the clouds.
Oh, there it is. Oh, it's
There's a nice
it's
little, I
shadow
think that's the
with a
actual
light
umbra.
shadow.
Yeah.
That could have been the middle of
that
the moon
was-
shadow,
yes,
which
yeah.
is the most intense and darkest, and it's only about
Here we go. Here's a better example of it. So we're
look at
pass under the penumbra, which is
the big one.
The big
right?
shadow,
But
right?
you see that the dot in the middle, I think it's going to pass again anyway,
Yep.
is much smaller. It's 250 miles long and only about 95 miles
There we are.
wide.
So
there it
that's
is.
a total eclipse shadow
And that's
there.
the shadow that's only passing over the Faroes and Svalbard
Yeah.
later on
I was
that
gonna
morning.
say, it's a very complicated shape, as you can see. And the way I understood it is, if you imagine shining a torch on a ball and moving it around, then you see the shadow on the wall behind you. But sometimes it's oval and it changes, you move around, it darts around. And then also the added complication is this is a sphere.
Exactly.
So the upshot of all that complex geometry is you get this rather the partial shadow, which is where we're going to
Yeah,
be, the
yeah.
partial eclipse, and then this tiny total solar eclipse.
And also the
movement off.
speed of it will vary depending on where it is on the globe. So when it first hits just underneath Greenland, it's going at something like 28,000 miles an hour, but over the Faroes, it's 2,000 miles an hour. Still far too fast for us to
Now,
keep
is
up.
this the same airplane that we sent you up last
It
year to
is,
look at the
it is.
Northern
Different
Lights?
cameras, obviously, compared to capturing the aurora, but still quite a complex challenge, because we've got to be in the absolute perfect orientation, flying at the right speed, at the right altitude, not to lose contact with our receivers back down in the Faroes. And we've only got about 2 minutes, 30 seconds to get the total eclipse
And
for
you
you.
can chase it a bit.
We
You
can
chase the shadow.
We're
and
going
elongate
to
the
have a few more seconds. We may have as much as maybe
Because you're
20
traveling.
seconds compared to people on the ground.
You've seen an eclipse, and it is something you'd recommend.
Oh, I did. I saw one in 2009 in Varanasi in India. Spectacular. 1 million people on the banks of the Ganges. It was a very long eclipse. I think it was about 4 minutes, the longest of the century. And what I remember is the sky going dark, and then suddenly, as you're plunged into night, I got this feeling that I was on the surface of a planet. You know, I was on a globe, but you were exposed to the sky, as it were, because of the rapid change. And I felt I was in space, which is absolutely
I
There's
can't
something to look
wait.
forward to. That'll be about 20 to 10 on Friday morning.
Friday morning,
Yes.
but I'll see you from the Faroes tomorrow night. anyway.
Thanks, Liz. Well, that's something to look forward to at the end of the week. But in a moment, we're going to be talking to someone who's landed on the moon, Buzz Aldrin. In my opinion, the Apollo missions were our civilization's greatest achievement. One of the reasons I got interested in astronomy. And so I was more than excited to have a go at landing on the moon myself. Inside this building is the world's largest moving base simulator. Built to help NASA engineers design the craft that carry human beings into space. Every shuttle astronaut has practiced the landing and rollout of the space shuttle in this simulator. But here's the reason I can barely contain my excitement. You can also do test spacecraft, in particular Apollo. And today, it's going to simulate the Apollo lunar lander. And I'm going to fly it with the man who test flew it for the first time in Earth orbit on Apollo 9, Rusty Swigert.
Hi, Brian.
Rusty.
Welcome to NASA's Ames Research Center.
Alongside Apollo 9 crew members Jim McDivitt and David Scott, Rusty blasted into orbit on the 3rd of March, 1969, my first birthday. Their mission was to test fly the lunar module that would deliver Neil and Buzz to the moon. In the days of Apollo, the only way to test NASA's new equipment was for astronauts like Rusty to try it for real in space. In the Apollo days, you didn't have a simulator like this, but You had them, of course. What were they like?
For the time, they were very sophisticated. But remember, that was 50 years ago. So I have much more capability in my cell phone today than we had on the Apollo guidance computer that took us to the moon. That's hard for people to believe, but it's really true.
This is what simulators looked like in the Apollo days. A cockpit strapped to a jet engine, affectionately known as the flying bedstead. It nearly killed Neil Armstrong. Simulators have certainly come a long way since then. Here at NASA, a team of control room engineers can conjure up an incredibly realistic virtual reality. Everything from the view out of the windows to the control panel displays can be accurately replicated.
I like to think of this place as the anti-surprise laboratory. Okay, we want to see what things are going to be like here, not wait till we're in actual flight.
The simulated motion is so realistic that we both need to wear harnesses. I should say, no one has been able to offer an adequate reason for these straps and carabiners.
It's so that you don't die. Don't worry about it, but that's why it's there.
It's so that you don't die, don't worry about it. I like that. That's the spirit of the 60s, isn't it?
That's right. Stand by cockpit.
You can feel it. It does move pretty quickly. Before I'm trusted with the controls, Rusty showed me how it's done.
Operate. Okay. So I'm rolling left, pitching up a little bit.
The aim of the game is to land in the middle of the target on the virtual lunar surface.
The vertical speed is correct. Yeah, but now we're heading to the center of the pad. I'll go down a little bit faster now.
A perfect landing. Clearly, Rusty hasn't lost his touch.
If you're over here, you can see the American flag. We don't have any UK flag, sorry.
One day.
Okay, now right seat has control.
Now it's my turn.
You have disabled controls, Rusty.
We're right up to you, Brian.
Operate.
Okay, there you go.
Rusty made flying this thing look easy. As for me...
Oh, this is terrible. I think we would have aborted by now. Are we, well, we're crashing. Yeah. Okay. Right. Right.
If I was a lunar module pilot, I'd have killed us both. But the great thing about a simulator is I get to have another go.
You got it.
I don't have the training of an Apollo astronaut, but I've got technology on my side.
Yep, perfect. There you go. There you got it.
The computerized controls give me a lot more help than they had in the Apollo days. And of course, I can ask for help from a man who's done it before, a luxury Rusty didn't have on Apollo 9.
Get down to close to 100, and then I'll tell you to hit the button. Now you can see the target coming in. Okay, another time. You didn't even use too much fuel. Roll angle is wrong. Congratulations, you're all great. Congratulations, we lived through it.
Yeah, I made it down. Now here with us is Dr. Buzz Aldrin. He was lunar module pilot for Apollo 11, the first Apollo mission to land on the moon in 1969. Buzz, it's wonderful to meet you.
Great to meet you, Brian. All right.
Buzz, when I flew that simulator, it was a modern simulator. There were lots of digital aids there, and I had Rusty Schweigert telling me what to do, and I still crashed it the first time. So, but how much more difficult was it to fly Apollo 11, to fly Eagle down onto the moon?
Well, the control system was really quite good. Once the astronaut took over, when the computer was flying, it was very easy. You just kind of watch it do what it's supposed to be doing, and it did that very well. But the control system was such that if you move the controller just a little bit, it'll command a rate of attitude change.
Yeah, so we've got a model.
And then if you let go, it'll hold just exactly what that is.
So you just roll forwards and backwards, and that's the control that you had?
Yeah. Well, yeah, you can roll back and forth and yaw.
Was it more like flying a helicopter?
It was very much, because all of us who were lunar module pilots or commanders were flying helicopters for maybe a year beforehand.
And we've got some video of Apollo 11 here. So the descent, I think when you listen to the audio, you got quite busy around 2 minutes before descent. Is that when Neil took manual control and you had to work together to get it on?
Yes, may have been a little bit, yeah, about 2 minutes probably, at 500 feet. That's where the commanders took over.
Yeah.
And if it was going right, well, they'd take their hand off the controller and they'd just keep going. But I could see the shadow. That was the landing gear pad. And then there was dust moving out like this.
Yeah. So you've got one window each, relatively small window. When I was in the simulator, it's quite hard to see down. You had to lean forward. So was it difficult to see?
I think that's the way the simulator was built, not to let you use the window, but for the simulation controls, instead of looking out the window.
And I have to ask you, was it? You must have been a bit nervous, although test pilots don't get nervous, I suppose you'd say. But it must be 2 minutes from the moon. What does that feel like, getting that thing down onto the moon?
Well, it all takes about 11 minutes, and 9 minutes are behind you, and 2 minutes are ahead of you.
And I have to ask you,
so now you're moving along on final approach.
And I have to ask you that famous moment, the call, was it Charlie Duke in Mission Control?
Yeah.
He said 30 seconds of fuel. And you hear yourself and Neil you don't really bat an eyelid. You just think...
No, because at 60 seconds, we were still a ways above the ground. Yeah. And I was kind of hoping that Neil would be as concerned as I was and kind of move it down. But at 30 seconds, we're only about 10 feet.
Oh, so you
and if the engine could have quit, it would have been a hard landing, but
you would have been down.
We'd have been okay.
That's impressive. You landed it on vapors, essentially. You landed it on
15 seconds.
I'm going to bring in Tim O'Brien, who's in charge here at Jodrell, because we knew that the eyes of the world were on you. But actually, even Jodrell was mapping your descent at this stage, and you found some.
Yeah, this is one of our most prized possessions. Yes. Actually, is this chart from our 50-foot telescope that tracked you down onto the moon.
Now, this was not tracking a beacon.
It was tracking one of with a carrier signal from the lander.
So this is the computer descent, very smooth. And I think that's the point where you took over manual control. And then there's quite a lot of flying going on before you got down.
Yes, we extended the landing to land on the other side of where the crater and some boulders were.
So that was
of course, that's the gentle thing to do, but it takes more time, and that's more fuel.
So that was just because you looked out and you saw there were some rocks, some boulders, a crater, so you had to take control and take it over.
All those little bumps are all when the pitch angle of the lander has been adjusted, I think.
I don't know the time scale, but this might have been when Neil took over and was adjusting to see what it felt like, and then he was sort of letting it do its thing, and then leveling off and pitching forward to move over the landing site.
A wonderful thing you said, to see what it felt like, because of course you hadn't flown this aircraft before, this spacecraft.
At all. I mean, you never get to fly it except the one time you're going to land it.
You've got to get it right.
Tim, this wasn't the only thing you were looking at that day.
No, I mean, in fact, the serious business for us was actually going on with the big telescope behind us here. So we were actually tracking this the Russian spacecraft that was orbiting the moon at the same time. This is Luna 15.
So the Russian sent up a spacecraft, which was unmanned, and the idea was that they would grab some soil or some rock, bring it back, in some ways to spoil your party.
Yeah, to bring it back before we came back.
And did you know that at the time?
We knew that it was probably going to do something like that, but it had to land safely. Yeah. And of course it didn't.
So what happened to it? What happened to Luna?
Yeah, well, so we were tracking the signal. You can effectively hear the signal. You can tell how it's moving. You know as it's flying towards the moon, and it basically got faster and faster. It didn't slow down fast enough. It was obvious it was going to crash. And in fact,
now, this was skin tracking. You weren't getting a.
It was just on the Doppler. It was just on the frequency shift of the carrier from the thing. Yeah.
We've got some audio of the control room on that night, actually, which we've been playing. So Sir Bernard Lovell.
This is Monday, July the 21st. The noise we hear is from the Lunik 15, and there has just been a rumour from a source in Moscow that this Lunik is going to land this evening.
A rumour from a source in Moscow. And then I think we have another recording of him getting very excited, Bernard Lovell.
Because the Luna crashed while you were actually on the surface of the moon.
So right. 2 hours before you took off from the surface of the moon, this thing crashed into the moon.
All of which you were from here.
If I just lean over, it didn't miss you by much. So I think you were in the Sea of Tranquility, which is I should ask you, actually. You should know this very well.
You were there. Give me the dark side and the light side.
Yes, crashed in the Sea of Crisis, which is there.
Yeah. It was a crisis for them, all right.
Yeah, absolutely.
Well, it didn't miss you by much. That's what worried me.
That's a lot of miss.
It's 700 miles.
Were you aware about that? Did you know that they crashed while you were actually on the moon? Had you heard that before?
I don't think. We heard it crash somewhere.
Right, okay.
We may have gotten the details, but it's been a long time.
What did Bernard Lovell say about it at the time?
We've got a recording of Sir Bernard.
And we were pretty busy.
He said, I say this is really the drama of the highest order.
Fantastically English way.
You know what
to react to this.
you know what we were doing about 2 hours before?
What?
We were pushing in the circuit breaker to see if it would stay, the one that had broken off.
Oh, yeah, because very famously, I've got to say, so you launched it with a pen, didn't
We're going
you?
to get all this story later, because this is a great story. One of the great stories. I want to hear the story in full. We'll have more time. We'll have more time for these stories, which we could have all night. Plus, any questions you would have for Buzz, please send them in to us, because this conversation will go on forever.
Yeah.
The future of space exploration, however, may not be in the hands of humans at all. There's a growing field of research into developing robots to replace astronauts, or at least to do all the tricky stuff on their behalf. Over in Holland, the European Space Agency's Research and Technology Centre, ESTEC, is at the cutting edge of astrorobotics. Dallas Campbell is there right now.
Yeah, thanks, Dara. Amazing story from Buzz. I'm about, in a moment, to take part in the most advanced human-robot interface ever in space science. But before that happens, let me just tell you a little bit about where I am. I'm actually at ESTEC in Noordwijk, and this is the European Space Agency's main technical hub, if you like. And it's where all the European space missions are devised and built and, very importantly, tested. All that hardware needs to be tested for launch and to make sure it can survive the hostilities of outer space. Now, this particular, I'm going to actually come back and later on in the week and talk to you a little bit more about that testing, but this particular laboratory is the Telerobotics and Haptic Lab, and this is where the next generation of robot astronauts is going through its paces. But before we meet all this gear, let's just meet some of the robots that are already working in space to help us right now. We are entering an era where humanoid robots are becoming a regular part of the space crew. Kirobo flew to the International Space Station in 2013. His mission? To help combat loneliness. He joined Japanese astronaut Koichi Wakata, and together they conducted the first conversation between a robot and a human in space. And still waiting for his first mission is the German robot Justin, developed to carry out tasks without human help. The long-term goal is to send Justin to Mars to set up a base for future manned missions. Until then, he'll just have to amuse himself. NASA also has an eye on Mars. Their latest robotic astronaut, Robonaut 2, is being put through his paces on the International Space Station. At the moment, his limited artificial intelligence means he's only good for menial tasks, but his researchers are eventually hoping to use Robonaut as part of the crew. He'll be the one who's sent outside the spaceship, and he'll mimic every movement of the astronaut who'll be sitting safely inside. As humankind continues to push the boundaries of space exploration, could it be the robots who lead the charge? I'm with Dr. Andre Sheila, who's in charge of this laboratory here. So let's just talk about these two terms, telerobotics and haptics. So when I think of telerobotics, I'm imagining having a remote robot arm or some kind of bit of technology that I can control from a different place, using a wearable glove or something like that. But let's just talk about haptics. What are haptics and why they're important for what you do?
Right. Haptics relates to the technology of touch. In a simple example, imagine lacing your shoe while seated at a table. You can actually accomplish that without looking at it. And this is due to your tactile sense of the hand. You're fully relying on what you feel. Now, haptics and robotics in space combined allows you to actually extend your haptic sense to places more than 100,000 kilometers away. So in space, we can do exciting things like fixing satellites in orbit or doing assembly of technical facilities on a planet where astronauts can't access.
So basically, it makes our own limbs a lot more sensitive.
Right. It makes you sensitive what a robot feels in a far distance.
But can I just check? I mean, if you were designing an algorithm for sort of telerobotics on Earth, is it going to be different to having a microgravity environment, say, on the ISS or something like that?
That's the new information. It absolutely is. We have done experiments recently on the space station, the first experiments ever to do haptics in space, and we found out that actually humans behave very differently in space related to their tactile organs. So we have to adapt the design of our mechanisms and joysticks and so on to the space environment.
This is the bit I'm really, really excited about. This is the latest exoskeleton. So this is what it's all about. I can wear this.
Yeah, why don't you just slide your arm in?
I've been dying to do this all day.
It's a very intuitive controller, so you just slide your arm in and you're ready to go to use it.
So I should just point out, so we have a robot arm remotely at Jodrell Bank there in Macclesfield that you might be able to see on the screen behind. Right. So if I lift my hand up, hopefully, well, first, there you go. First of all, you can see it actually moving. Dara very wisely has his hands very far away from it.
It's about 300 kilometers.
See, that's amazing. So I can actually feel him now. I can actually feel him moving my hand.
More
as
than
if someone.
300 kilometers
Okay.
away.
Okay, presumably something like this could be used not just in space, but also on Earth as well in hazardous situations.
Absolutely. Imagine nuclear waste removal or operations deep under the sea in an ocean. This is absolutely where a human touch can actually help solve problems.
Dara, can I just ask you? Can you just tap the actual hand bit? I want to just see if I can actually feel.
Are you feeling that, Dallas? You feeling that? You feeling the pressure?
I can't feel you stroking. It's a little. Just give it.
There's a tap.
See that I can feel. See that is unbelievable. I can actually feel you tapping here.
How does it feel for you?
It's almost like somebody's in the room. It feels as if somebody's in the room just tapping my hand, which is incredible.
I'll tell you what, can you get hold of something? I've got a pen.
Yeah, can you lift? Can you?
Now the distance is more or less than the distance from here to there is the same than to the space station.
Here you go,
Okay, if
Dallas.
I open my little robot hand.
We've got a script here.
Yeah.
So I'll tell you what, Dallas.
Is that a pen in there?
Yes, if you can grab the pen off me. Ooh, there we are.
Try it again. Open up again. There
we
we
go.
Try
There
one
we
more
go.
time.
Now we've got a challenge for you, Dallas. Can you draw a smiley face on this script? Smiley face.
We'll hold it rigidly. Go on.
Go on, like the sun during the eclipse.
Go on.
Two eyes,
Oh,
an eye.
okay, gonna
Okay,
go.
no, you've got a bad grip on it. You've got a bad grip on it. Try it again. Open the pen
Have I?
again. Right, now close the hand.
Okay, I'm going to open.
Yeah.
I'm gonna open my gripper.
There we
There we
go.
go.
Now you have it.
Smiley face.
Okay, I'm going to try and draw a smiley face. So there's the face, and I'm just going to do a little eye and a nose and a smiley mouth for the eclipse. How's that? That work?
Oh, it's immaculate. Yeah. There.
There we
okay.
are. That's actually not bad.
can't see it.
I'm not sure what that bit is.
Well,
but it's-
listen, I'm patting you well done. I'm patting you very well done there, Dallas. Tap,
Thank
tap,
you.
tap, tap, tap. Well done.
Thank you very much.
Dallas. Can I have a pen back, please, Dallas?
And thank you,
Can I have
Mr.
my pen
Robot.
back? Dallas, I'd like the pen back now. Thank you very
No, I'm
much.
afraid you can't. That's mine now. No, that's mine.
Okay, thank you very much, Dallas. Lucy is outside under a very dark sky to tell us about a rare show that the planet Jupiter is putting on for us.
Yes, Jupiter is looking spectacular tonight. There it is. You can see those 4 small white spots perfectly lined up are the largest moons of this planet. We've got Europa, Io, Ganymede and Callisto. Now, they're all gathered on the right side of the planet at the moment, and this is a fairly rare occurrence to have them all lined up. As I mentioned earlier, it only happens every 6 years, and it's not going to stay that way for long. Each of those moons orbits Jupiter at a certain distance or different distance, and also with a different speed. So night by night, that pattern changes. Io, for example, the closest moon in and the most volcanically active place in the whole solar system, switches sides of Jupiter every single night. The other moons take longer to do this. So we will come back and see how that lineup looks tomorrow night. Now, one of the reasons we have such a good view of Jupiter at the moment is because we're not being washed out by the light of our own moon. That's visible only during the day at the moment. And of course, on Friday, it's going to clash with the sun and give us what we hope to be a spectacular solar eclipse. But in the coming days, the moon will become visible in the evening sky. I mean, it's a great time to go out and in those coming days do some moon watching, no matter where you are. I've come to the heart of London for a spot of sightseeing. But although I'm surrounded by world-famous landmarks, they're not tonight's star attraction. This might seem like an unlikely place for stargazing, but even the light pollution of the city can't wash out our view of the faithful moon. It's one of the most familiar objects in the night sky and the most captivating. But getting to know its top sites will transform this glowing disk into a 3-dimensional world of towering mountains, deep craters and waterless seas. Because it's so close to Earth, you don't need any specialist kit to pick out features on the lunar surface. It's amazing how much detail you can make out just with the naked eye. What's immediately obvious are large, flat, dark areas that are called mare, and that's Latin for seas. Despite their name, the mare are not seas at all. Early observers mistook them for water because of their smooth appearance. But telescope views like these have since revealed them to be huge expanses of frozen lava. In the centre of that dark patch is the Sea of Tranquility. It's 400 miles wide. That's greater than the width of Britain. And it's the most famous space landmark. This is where Neil Armstrong and Buzz Aldrin made their giant leap for mankind, taking the first ever steps on the moon. The astronauts of Apollo 11 saw a barren land of cavernous craters and steep mountain ranges. But all you need to explore further is a pair of ordinary binoculars or a small telescope. I can see thousands of craters caused by asteroids, meteorites and comets slamming into the surface of the moon. These craters are evidence of the moon's violent past. Some are billions of years old. You might be wondering why I'm not looking at the moon when it's full. At its fullest and brightest, the moon is a glorious sight and it dominates the night sky. But it's so well lit that many of its features are simply washed out. If you want to see the finer detail on the lunar surface, it's best to pick an evening when the moon is half lit and half in darkness. The line dividing light and dark is called the terminator. It separates the lunar day and night. Mountains, craters and valleys look especially steep and rugged when they're near the terminator because the low sun casts long, dramatic shadows, just as it does on Earth at dawn or dusk. I can see the Montes Alps. They were named after the Alps in Europe and they're actually very similar in shape and size. Imagine skiing down those with 1/6 of the gravity. Through a telescope or binoculars, you can take really impressive photos of the moon, even with a smartphone. One thing you can use your images for is to get a real sense of the scale of the landscape, because the length of the shadows cast by the features tells you how high they are. It does take a bit of number crunching, but by measuring the length of the shadows in this photo, we know this mountain, Mons Piton, rises 2,250 metres above the surface, twice the size of Mount Snowdon in Wales. I'll never tire of looking at our magnificent moon. It's mind-blowing to think that by simply looking up, we can explore a world that's 250,000 miles away in space. And night after night, we can scale a new mountain range or navigate across another of the lunar seas. Of course, the big payoff of having no moon tonight is that we can see many objects that would otherwise be simply lost in its glare. Well, that's as long as the skies are clear. So here with the weather update is Nina Ridge.
Thank you very much. Every day this week we've been breaking up the cloud. Today we had plenty of sunshine. That's left us with clear skies through the night tonight. A bit of an exception with some mist and low clouds coming in off the North Sea. That will obscure the view across parts of North East England, East Anglia and to the South East corner. So the clearest of the skies tonight are going to be further west, although there could be a little bit of mist and fog around. A pretty good chance of seeing Jupiter and its moons. Now the forecast for the partial eclipse not quite so straightforward. Matters will be complicated by this weakening weather front drifting its way south into our high pressure. It's not bringing with it much rain, but it is introducing a lot more cloud. So expecting this zone of thicker cloud to be sitting at the moment through Northern Ireland, southern Scotland and Northern England. Hopefully to the north of it, North East Scotland might just see one or two clearer spells. Our most favoured spot for viewing is likely to be through Wales, the Midlands and towards Lincolnshire, because the southeast corner at the moment is set to be stuck underneath some fairly thick cloud. So prospects tonight looking good with some clear skies, but for many on Friday morning it is looking fairly cloudy.
Well, that might be a pity unless you're in the Midlands, Wales, or indeed in Ireland, which is quite clear. But if it's cloudy where you are, don't worry. We'll get you a view of that eclipse from above the clouds. Now, with the solar eclipse only 36 hours away, another of the questions people are asking is, what effect will it have here on Earth? Well, the ocean tides are one thing that will definitely be affected, as Liz Bonan investigates with a very unusual group of surfers.
It's an early morning in January and the winter sun isn't offering much warmth. Not the ideal time for a dip, but along the river, that's exactly what groups of hardy surfers are planning.
I'll see you down there, all right?
This is the River Severn flowing through Gloucestershire. Just 40 miles away, downstream, this morning's high tide is about to reach its peak. And when it does, a huge body of water is going to come rushing up the river. It's called the Severn Bore. The bore only happens with the highest of high tides, and that's down to the alignment of the sun, the earth, and the moon. Oh, yeah, I can see it. There is a man surfing on a river. This is such an extraordinary, surreal sight. Amazing, amazing. One guy on a canoe, two surfers, on the most glorious winter's morning. It doesn't get much better than that, does it? So what effect will the eclipse have on the tides and the Severn Bore? Now imagine this is planet Earth, this smaller boy is our moon, and then this rope is going to represent the oceans of planet Earth. Now, the moon's gravity has a marked effect on our planet and its oceans, with the effect being felt most strongly on the side of the planet that's facing the moon. Complex forces are at play here, but essentially what it results in is a sort of pulling of our oceans towards the moon on this side and away from it on the other side. Now, imagine Great Britain's here. You pass a high tide and then a low tide here, and then another high tide, and a low tide every 24 hours. But the level of high tide varies each day. That's because the sun has a part to play too. When the sun and the moon are on the same side of planet Earth, the tidal effects are combined, resulting in even higher high tides, what we call spring tides. And that's the case during the eclipse. Now, our moon's orbit is oval, so sometimes it's closer to us than others. The closer it is to planet Earth, the more its gravitational effect will be felt, and the higher the tide will be. On March 20th, the moon is very nearly at its closest to Earth, what's called lunar perigee. But that's not all. During a total solar eclipse, the moon isn't just on the same side as the sun, it's precisely aligned with it. And so the two are pulling in exactly the same direction. Now, if you combine that with a lunar perigee, and you've got near perfect conditions for spectacularly high tides, and that's what's happening on March 20th. The surfers here are not going to want to miss that wave.
There is an irony here, of course, because while eclipses cause high tides, one day high tides will spell the end of total eclipses.
Yeah, essentially this gravitational interaction between the moon and the Earth also acts to slow the Earth down. So that means that the length of the day gradually increases, but spin, or more precisely angular momentum, is something that's conserved. So if the Earth loses spin, something's got to take it up, and it's the moon. So what happens is the moon moves further away from the Earth by 3.7 centimetres a year. We've measured that, by the way, with a mirror that Buzz and Neil left on the moon, and we bounce lasers off it, and we can tell that. So the moon moves further away. That means that it takes more of the spin. And so the day shortens, the moon moves further away, and in around something like 600 million years, then the moon will have moved further enough away, exactly 14,550 miles, in fact, that it's then too small to cover the face of the sun, and there will be no more solar eclipses.
And that's the great cosmic coincidence that we'll be enjoying on Friday. Now it's time for our annual Citizen Science Project, where we get the chance to use you as a collective to make advancements in scientific discovery. Scientists are literally queuing up genuinely to bring us raw data for you to look at, because it's been so successful. In 2012, we discovered many exoplanets, including Treponton Holmes B. In 2013, we mapped areas of Mars that had never been viewed before and discovered many features on them. Last year, we discovered a hidden distant galaxy, and it became proper science.
Well, here it is, it's proper science, because there's the paper that's going to be published tomorrow. It says the red radio ring, a gravitationally lensed hyperluminous infrared radio galaxy, Z equals 2.55. That means that the light has been travelling 10 billion years to get from that galaxy to us, and we discovered that, and it's been published. It's a real genuine piece of science.
This year, we're hoping with your help to revise the known age of the universe.
We should just repeat that.
Yeah.
No, it's about 13.8 billion. It will be more accurately known after stargazing if you help us.
Yes, to do that, we are chasing massive exploding stars. Supernovae, this is a simulation of what they look like. It's the most dramatic and powerful event in the universe. Not just the explosion, but then the huge debris cloud which is thrown off by it.
Well, yeah, and they're important. There are two types, actually. So this, what we're showing here, is the type when a star runs out of fuel. So it runs out of fuel, it collapses under its own gravity, it explodes. You distribute heavy elements out into the universe. So at the Big Bang, there was only hydrogen and helium. The carbon and oxygen that we need to exist, the things that make up our bodies, were forged in the hearts of stars during fusion reactions. They're distributed when those stars explode. But also the heavier elements. If you've got a wedding ring, so platinum, gold, silver, those are made actually in the explosions themselves. It's the only place in the universe where the conditions are violent enough to produce those heavy elements. But supernovae aren't just spectacular things to look at. They can also be used to discover things about the universe, like, for example, its age. And here's Chris Lintott to tell us how you can help.
Chris, what is the task this year?
Well, we've been using telescopes to scan the skies for supernovae because we know these things happen all the time in the millions of galaxies that we can view across the universe, but we don't know where they're going to go off. So we've had a telescope in Australia called SkyMapper look across the sky in the last week, and it's recorded hundreds of thousands of images where we think something has changed.
By all the time. They're rare, aren't they? Is it one per galaxy per century?
That's about right for a Milky Way type galaxy, but because we've got millions of galaxies, and because they're so bright that they can be seen from halfway across the observable universe, we can pick these things out. But the problem is distinguishing them from other things that move, so asteroids zipping past, variable stars that change brightness, and that's the task that we want people to help with tonight.
And how can those supernovae help us determine the age of the universe?
Well, if you get a particular kind of supernova, which we hope will be lurking in the data, it's called a Type 1a, but that doesn't matter. They always go bang with the same luminosity, the same power. And so if you know how bright they were when they went off, and you know how bright they appear, you get a measure of distance. If you've got a measure of distance, you can work out how the universe has expanded, and therefore how long it's been expanding.
So what do people need to do?
What we need them to do is go to a website, it's called Snapshot www.supernova.org, or you can go to the Stargazing Live website. There's a link on the front page. That will show you the candidates that our Australian friends have gathered, and you'll get 3 images like this. So this is an image from the last few days. This is an image from a library photo, essentially, and this is the difference. So you can see that there's something new here that wasn't there before, and that's what we're looking for. And then we ask people a series of simple questions to help us divide the supernovae from the other stuff. The computers can't do this. That's the point.
And if we see one, if someone finds one, what do we do then?
Well, we've got a telescope in Chile standing by. So the data's from Australia. We're here in the UK. There's a telescope in Chile standing by. And sun sets in Chile just before midnight, our time. So we've got until then to send them a list of
if
candidates.
people go online now and find good candidates for this, there is a team in Chile ready to spin the telescope.
That's right, and they'll be able to tell us what type of... So they'll be able to confirm that these are real, and they'll tell us what type they are as well.
What I love about
We've
this,
got
it's
2
urgent.
hours.
Yeah, that's exactly it, because it's not like the planet hunting where the planet's already there waiting to be found. These things go away in a week.
That's right, and here's the thing. If we don't catch them tonight, the light will be long gone, and we'll never know that these things were there.
We've got to get out there and do it.
Do that. If you fancy having a crack at changing the age of the universe, or at least our estimation of it, now is your chance. We'll update you with the supernovae search tomorrow night. Thank you very much, Chris. It's very kind of you to come in. Now, that's your task. Of course, when Buzz and all the other Apollo astronauts went to the moon, they had many scientific missions as well. And one was to bring back lunar samples, and they didn't come back empty-handed. They brought back bags full of moon rock. But 40 years on, what's happened to it all? This is the Johnson Space Centre's Lunar Sample Lab, home to 382 kilograms of rock and dust. Sealed in cabinets purged with high-purity nitrogen gas, these rocks are as fresh as the day they came off the moon. But not all of the rocks have been so well looked after.
We'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol of mankind and we can live in peace and harmony in the future.
Following Apollo 17, the final mission to the moon, President Nixon ordered pieces of the rock to be given to every state and to every country around the world. Known as the Goodwill Moon Rocks, they were to be a symbol of human endeavour and global peace. But it didn't take long for them to start disappearing. Despite his best intentions, Nixon had unwittingly created a black market for moon rock, and almost all of it was fake. From door-to-door salesmen selling soil for a few dollars an ounce, to the brothers who tried to auction an ordinary pebble for $400,000. In an attempt to stamp out the illicit trade in lunar counterfeits, NASA called on this man, Special Agent Joseph Goodheinz.
I'm going, we got all these victims out here. There's something wrong here. We should be proactive. We should con the con artists.
So Joe set up a sting, Operation Lunar Eclipse.
What I decided to do was create a fictitious company, John's Estate Sales. And in September of 1998, I put an ad in USA Today. Moon rocks wanted.
Joe received his first call.
Hi, my name is Alan. I think I might have something you would like. My phone number is 555.
Just as Joe hoped, a conman had taken the bait. He claimed to have a genuine moon rock for sale and directed Joe to a website to prove it. Nothing had prepared Joe for the image he was about to see.
My God, this looks like the real thing. Either it was the most intelligent con that I'd ever seen, or one of the Apollo 17 Goodwill moon rocks that we gave to the nations of the world.
Could this man actually be selling a genuine Goodwill moon rock? Joe went undercover and met the seller in a Miami restaurant.
We had a team of U.S. Customs agents about 2 blocks away that were monitoring our operation.
And they made a deal where Joe agreed to buy the moon rock for a whopping $5 million. The seller revealed that the rock was stashed at a nearby bank vault. Joe wasn't about to hand over all that cash. He was going to need one final ruse.
What we told him we were doing was we were snapping a picture of the moon rock to confirm that he had it before we could go ahead and buy the moon rock for $5 million.
Posing as photographers, 2 undercover agents agreed to meet the seller at the bank. Would he be lured into Joe's trap?
When he walked into the bank, we seized the moon rock. Mission accomplished.
Joe had recovered the piece of moon rock given to Honduras back in 1973. Although retired from NASA, Joe's mission is to hunt down all the missing rocks.
We're missing Spain's moon rock. We're missing Malta's moon rock.
He has 170 to find.
We're missing so many of the treasures that our astronauts risk their lives to return to Earth. We should make every effort to get these moon rocks returned.
Now, Buzz is with us again, as is Britain's Apollo 17 Goodwill Rock. This one has been very carefully looked after by the Natural History Museum since 1975. Tonight, it's accompanied by Stuart, its very own security guard. I'm supposed to ask you a question about the collection of moon rocks. I don't care. Tell me the pen story.
The pen?
Yes.
You mean the circuit breaker?
Yeah.
Yeah. Well, we'd come back in again, and from being outside...
You've done the moonwalk and everything, you're better leave.
Yeah. And so we got ready to sleep. See? It was chilly in there. And I took dibs on the floor. So I lay down on the floor with my head toward my side, which was the right side, co-pilot side. And as I looked down, I saw dust that we'd tracked in. But there was a funny, peculiar object. It shouldn't be there. It was about this long. And it sure looked like a broken end of a circuit breaker. And I picked it up, and sure enough, well, there were rows of circuit breakers on both sides, but this came from my side. So I went up and looked to see which circuit breaker it was. Engine arm.
So it was the ascent engine.
That's the one you got to push in when you get ready to land. Then you land and you pull it out. But you got to, when you get ready to leave and go home, you got to push it in again. But it's broken off. We missed a great line. Houston, we got a problem. So anyway, they worked it over, and instead of waiting until maybe 5 minutes before launch, they said, maybe we ought to find out whether it worked or not. And so I didn't want to put my little finger in there to push it in, or a metal ballpoint pen, but I had a felt tip pen. And so I used it and pushed it in, and the people back on Earth in Houston said, yes, the circuit is complete, it's made. And so now when the computer turns the engine on, it'll work.
And then you went to sleep?
No. This was the next morning.
Oh, right, so
it was about 2 hours before liftoff.
So the only reason you took off is because you happened to have a spare felt tip pen that managed to jimmy it.
It wasn't a spare, it was the only one.
The only one. But we've got a couple of questions here. We've got a similar question from Aaron Cameron, age 7, and also from Solly Moxon. They're asking about spacesuits, because you also did one of the first spacewalks on Gemini, didn't you?
Yes.
So the questions were, what's it feel like on the moon and doing an EVA on Gemini?
It feels quite natural, because I'm used to diving, scuba diving, and that's why I welcomed the suggestion that we could train for spacewalking underwater. Neutral buoyancy, and of course you've got pressurized suit, so you float unless you put weights to be neutrally buoyant. But once you're like that, well, you're just sort of floating underwater, just the way you would be. And as long as you're not moving real rapidly, like you might be on the moon. It's not a good simulation of walking on the moon, but being outside the spacecraft and doing other tasks. It's very excellent.
We have a million of these questions. You're going to stay with us, I know, and so we're going to ask you more and more of these questions. We, however, have to run out after this show. We're only going to be here in like 2 minutes' time.
All night long.
And tomorrow. Okay. Yes, Buzz will be with us both later and tomorrow. But now, over to Lucy for one last look in the night sky.
Thank you very much. Well, amazingly, we've had clear skies all night tonight. Liverpool Astronomical Society have popped back in for Back to Earth, which gives me time just to talk about one last thing. Now, earlier on in the programme, we were talking about the search for supernovae, and the next thing that might go bang in our own galaxy is a star called Betelgeuse. And actually, you can see that in our cameras now, or pop out and have a look for it in the constellation of Orion. It's a supergiant star, absolutely massive, would fill half of the solar system. But there's going to be lots more coming up in the following nights, so for me, I need to head inside, and it's goodbye for now.
Thank you very much, Lucy. Now, if there's anything else you want to ask Buzz, please send your questions in. We're going to be right back here on BBC Two with Back to Earth, but with Buzz and other experts. So I suppose we're going to see you in about 2 minutes' time.
Yeah, I think so. And I've got about 150 questions to ask you. So send them in. Over there in 2 minutes.
We'll see you there.
5 degrees to this plane. So very often, you can imagine, and this is also moving around, it's quite a complicated system, very often the moon will be casting a shadow, but because it's above the Earth, the shadow it casts will be out somewhere in space. And then at some later point, as the moon moves around, it could be below the Earth, and then it will be casting a shadow below the Earth. So it's only when the geometry is just right that the moon aligns correctly that a shadow is cast from the sun to the moon onto the Earth and you get an eclipse.
So it's rare that you see an eclipse, but it's particularly rare, and we're the only planet in the solar system that you get a total eclipse. But there are other eclipses throughout the solar system.
Oh, there are, yeah. I mean, this is a beautiful picture. So this is a picture from the surface of Mars, of an eclipse by Mars's moon Phobos. Now, Phobos is about 27 kilometres across. It's a very small moon. As you see, it's not close enough to Mars to completely obscure the sun. But this is a photograph from Curiosity, actually, on the surface of Mars.
This is a photograph taken by a robot we sent to another planet of the planet enjoying an eclipse.
Emphasising that, isn't it? Beautiful.
It's astonishing. Our challenge, therefore, this week is to bring you the very best images of Friday's eclipse. And here's our secret weapon, Liz Bonin.
I've never been called that before.
No, okay, Grant. Maybe the sentence ran on in a way that was unfortunate. But Liz, firstly,
are you shaking my hand?
I am, because
Thank
you've been
you,
here for
Darragh.
5 years, but you've never been here.
5 long years, and finally I make it to John.
We always send you off all over the world.
I know, I'm not that I'm complaining or anything, but it's really nice to be here. Yeah.
However, we only have you for the one night because you're heading straight off.
I'm heading off in the morning and then I come back for Friday night's show. So you have me zipping up to the Faroes and back, because as much as the larger shadow of the moon covers all of the UK, we get as much as 98% coverage of the sun. The path of totality, as it's called, is passing us by about 150 kilometres.
You cannot look directly at the sun without there being a fairly heavy filter. Right?
This is becoming our image, isn't it?
Yes, this is our thing now. But if you can't get a hold of these, and they are difficult to get a hold of, please go to our website for other ideas for watching it safely. Do not look directly at the sun, because you can do serious damage to your eyesight. This is what you'll be seeing, however, depending on where you are. It could be up to 98% of the sun will be obscured by the moon. This is an animation of what it'll leave, the small smile of the sun at the bottom there. And on top of that, we'll be bringing you live an even rarer event. 230 miles north of Scotland in the Faroe Islands, we'll see a total solar eclipse. Now, a total eclipse can only occur because of a very beautiful coincidence. This is one of the great things about, with Stargazing. Something as beautiful as this would occur. Right? This is the sun we want here. Lovely, very, very good.
We should say the puffer sphere is back.
It's good to have our old friend, the puffer sphere, that's spinning around there. This actually flatters the moon to a certain extent, but the sun is 400 times larger than the moon. But luckily for us, where the moon is right now, it is, and this might be a difficult one to get exactly right. Here we go. Oh, there. The moon is 400 times closer than the sun is. So the moon sits directly in front of the sun, creating a total eclipse. Now, the thing about this seems very obvious in some ways, but there's one thing that always puzzles me. If the sun is here and we're here, if the moon is just going around, why does an eclipse just happen every month?
The answer is because everything isn't in a line. So you change to the Earth. So indeed, you're right. If the moon orbited the Earth in the same plane as the Earth and the sun, this is called the plane of the ecliptic, by the way, then you're right. Every month, the moon would cast its shadow on the surface of the Earth. But it's more complicated than that, because the moon orbits the Earth at an angle of about...
Good evening and welcome to Stargazing 2015. What a beautiful night we have for it here. This week sees the UK's biggest astronomical event of the century so far, a nationwide solar eclipse.
We'll bring you images of the eclipse from across the UK and explore the majesty and the detail of this extraordinary event.
And as we gaze at the moon, who better to join us than the legendary Buzz Aldrin?
I'm Brian Cox, he's Darragh O'Brien, and this is Stargazing Live.
Welcome to Jodrell Bank Observatory in Cheshire. This will be our home for the next 3 nights. We will take you from here to the moon, to Mars, and from planet Earth to Pluto.
All that and Buzz Aldrin. Buzz was lunar module pilot for Apollo 11, the first manned mission to land on the moon. Find out whether he thinks our future in space is on the moon, on Mars, or beyond.
Brian's going to be trying his hand at a moon landing with various degrees of success.
Yeah, well, we're crashing.
Yeah. And we'll find out how astronomers ancient and modern can predict solar eclipses so accurately.
We'll take you behind the scenes at Europe's Spacecraft Test Centre, where they make sure the latest space probes don't fall apart on the launch pad. And over the next 3 days, we'll be searching for exploding stars, supernova explosions. With your discoveries, our aim is to revise the known age of the universe.
It's a fabulous night for stargazing, and as ever, we want your stargazing pictures. And of course, we're also here to answer questions. We're here, and Buzz Aldrin is here. So if you have any questions, for example, about walking on the moon, solar eclipses, or space missions, the addresses you need are on the screen right now.
Now, it's time for our first look at what's in the sky tonight. And to do that, here's the newest member of our team, solar physicist Dr. Lucy Green.
Well, thank you, Brian. I am delighted to be out here, although I'm sure you are a lot warmer inside. But I'm joined by a gang from the Liverpool Astronomical Society. Give us a cheer, guys. And just look at this, we have fantastic clear skies at the moment, and we're getting a great view of Jupiter, and you'll be able to see the 4 largest moons perfectly lined up on one side of the planet. And this is a rare event, only happening every 6 years. Now in the coming nights, this alignment is going to change as the moons go through an extraordinary dance. More on that later on. Please keep your fingers crossed that the skies hold out for us.
Yes, so the moons of Jupiter will be performing for us this week, but that's really only the opening act, because undoubtedly the biggest treat of the week will be on Friday morning, when a solar eclipse will be visible right across the UK. This occurs when the moon gets in the way of the sun and blocks out the light. Now, to view it, and we will say this many, many times, it will be helpful if you had one of these. These are a pair of eclipse glasses, because you can...
Northwest of Scotland.
So where are you going now?
So I'm heading here. The Faroe Islands just here, because that's where one of the only 2 places on Earth, bits of land, where you can see a total 100% eclipse,
right,
solar eclipse.
Because essentially what you're doing is chasing a shadow.
Yeah, I am. We really are chasing it, because not only am I joining about 8,000 eclipse watchers tomorrow night on the Faroe Islands, on Friday morning I'm going up 25,000 feet to really chase that shadow for you.
Above the cloud line.
Above the cloud line. That's the
we can actually show you the
part.
shadow. I think we can show you the shadow here. Here we go. Let's bring it around here.
I like this part. Can I play
Oh,
with
it's fabulous. Where are we going? Oh, for God's sake.
We've gone around the
planet. We've gone too far. Here we go. So,
okay.
Have we got the shadow graphic here that we
Here
show?
we are.
There we go. No, that's just day and night passing through. Okay, so you're going to go up there above the clouds.
Oh, there it is. Oh,
There's a nice little, I think that's the actual umbra.
Yeah.
That could have been the middle of the moon's shadow,
yes,
which is the most intense and darkest, and it's only about...
Here we go. Here's a better example of it. So we will pass under the penumbra, which is the
big one.
The big
right?
shadow, right?
But you see that the dot in the middle, I think it's going to pass again anyway,
Yep.
is much smaller. It's 250 miles long and only about 95 miles wide.
So
there it is.
Total eclipse shadow.
And that's the shadow that's only passing over the Faroes and Svalbard
Yeah.
later on that morning.
It's a very complicated shape, as you can see. And the way I understood it is, if you imagine shining a torch on a ball and moving it around, then you see the shadow on the wall behind you. But sometimes it's oval and it changes, you move around, it darts around. And then also the added complication is this is a sphere.
Exactly.
So the upshot of all that complex geometry is you get this the partial shadow, which is where we're going to be, the partial eclipse, and then these tiny total